So for part C, we want to find the absolute maximum value. And in part B, we already found what our local minimum is. So what we're going to do is we're going to check our endpoints. So we want to know what g of -5 is, g of -4, and g of 4. Because -5 and 4 are our endpoints. So what we're going to do is we're going to use our formula and substitute those numbers in. So I need to find the area under the curve from -3 to 5. Because I'm going from high to low, I'm going to use the properties of integrals to switch the upper and lower bound by making it to a negative. So I'm looking for the area under the curve between -5 and 3. So between -5 and 3. So notice that these two triangles have the same area. One is a positive, one is a negative. So that area is going to be 0. I need to switch the upper and lower bound for the second one as well. So now I'm looking at the area between -4 and 3, which is just the triangle. So it's going to be 1/2 the base times the height. So that's -1. And then the second area is going to be from -3 to 4. From -3 to 4. Okay, so I'm actually not going to find the area because I'm looking for my absolute min. And if you notice, this area plus that area minus this little area is still going to be bigger than -1. So this is a much bigger area. So my absolute min is -1, and it occurs when x is -4. So for part D, we want to find the point of inflection. So if you guys remember where the point of inflection of g is going to occur when the second derivative is equal to 0, or the second derivative does not exist, and the second derivative needs to change signs. So since this is the definition of g, the second derivative is the same thing as the first derivative of f. And because we are looking at the graph of f, that means that we need to look at the slopes of f. That's what the derivative means, the slope. So I need to find where the first derivative is equal to 0 or the first derivative does not exist of f. So notice that there's 3 places that the derivative is not going to exist. And there's another one where the derivative is equal to 0. So the f prime doesn't exist when x is -3, when x is 0 or 2. And when x is 1, the derivative is equal to 0. So if you look at the very first one, so now we're looking at slopes. My slope is going from positive to negative. So it does change signs from positive to negative. So therefore, this is a point of inflection. Remember that I have to explain in words as well. Okay, at x equals to 0, the second derivative does not exist, but my slopes are going from from negative to negative. So at x equals to 0 is not a point of inflection because the second derivative does not change sign. At x equals to 1, notice that my slopes are going from negative to positive. So that is a point of inflection. And then finally, at x equals to 2, it's also a point of inflection because the derivative does not exist and I'm going from positive to negative.